Hi everyone and welcome to my talk. I'm Thomas, the guy that you see in the picture here, and I'll tell you something about PRTest, the plain random tester of Test-Comp' 2021. The idea of PRTest is that whenever we as researchers create some new approaches or new techniques, we implement a prototype for that or a new tool, and then we compare it to its predecessors or some other existing tools like the state of the art. But often we do not compare our approach to a very naive or simple approach, something like purely random approaches or monkey typing. And PRTest tries to be this naive approach for Test-Comp', but also in general. So I hope that in the end, some of you may think about using PRTest for your own evaluations. All of the magic of PRTest is in the testing harness. This testing harness is some C code that defines input methods and a special main method for running the original program under test as fast as possible. So this test harness is compiled against the program under test, and this creates a single binary which is run. At the very beginning of the execution of that binary, there's a small test setup defined by the test harness, but immediately after that, we just execute the original program. During that native execution, whenever there's some input method called, we use the definition of the test harness to create a new uniformly distributed random input and remember that. After program execution, we place a test filter to check whether the execution actually covered anything new. If the program execution found some new branch, we write the test to the output, so it's part of our test suite. And then we just repeat the same over and over again. So this can be very fast because it's native execution, and the only bottleneck is the program execution itself. But because we only use uniformly distributed random inputs without any special heuristics or any test generation strategy, PRTest has a very hard time creating inputs for unlikely program branches. In Test-Comp', we see that a lot in the ECA categories, where we have programs with lots and lots of conditions in the if statements that are very specific. In addition, because we try to be fast, we do not fully reset the program heap between program executions. So if there are some global variables in use, we do not reset them, and we may produce invalid tests or miss some tests that we actually could create. We did not encounter this as a problem in Test-Comp', but it's something that we definitely should keep in mind. On the plus side, PRTest is very fast, so we can create millions of tests per second. We support all language constructs and features of C because we natively compile and execute the program, and I hope at least PRTest is simple and easy to understand, so it should be a good baseline, so very basic. And then it gets interesting when we look at the Test-Comp' 21 results. So whenever PRTest is not the last place in a category, that's a hint that the tools that are worse use some approach that or some heuristic that is not suited for the corresponding category. So in the coverage error category, there are two subcategories where PRTest is not the last place. In floats, it's the 7th place, so there are 4 tools that are worse. And in loops, PRTest is the 4th place. So there are only 3 out of 10 tools that are better than PRTest in finding a single error location in the loop category. So it's interesting to look at the result tables in detail, check which tools that are and why they perform worse. So maybe these tools could benefit from some randomness. If you're interested in using PRTest or trying it out for yourself, you can find it online. It's open source. And if there are any questions or issues, I'm always happy to help. Just drop me an email. Thanks for your time.